Let's dive into a practical session focusing on ElastiCache. We will begin by setting up a Redis instance of ElastiCache, though it's important to note that Memcache is also available as an alternative. For this tutorial, we'll proceed with creating a Redis cache, which provides numerous configuration options. One of the standout choices is a serverless configuration. This allows your cache to automatically scale in response to your application's traffic, eliminating the need for server management. Although this option tends to be more expensive, it significantly simplifies administration. However, for this tutorial, we'll opt to build our own cache configuration. This approach will give you a clearer understanding of how to design a caching solution using AWS efficiently. Now, let's explore the various methods available when creating your cache. You can either restore from an existing backup or utilize the Easy Create feature. This feature will help you quickly set up configurations that follow recommended best practices suited to different environments such as production, development, testing, or even demo scenarios. Ultimately, the choice will depend on your specific needs. If you prefer, you can also take a granular approach by configuring all parts manually. For our setup, we will leave cluster mode disabled. This means our configuration will consist of a single shard with one primary node and up to 5 read replicas. Should your application require scalability, enabling cluster mode allows for multiple shards across different servers. Next, we'll simply name this instance Demo Cluster. While the default location will be within the AWS cloud, you also have the option of deploying ElastiCache on premises through an offering called AWS Outposts, which extends AWS infrastructure to your local data centers. When it comes to high availability, consider whether you need multi-AWS, availability zone, deployment. This feature can enhance resilience by providing failover options if the primary node encounters an issue. For cost-effectiveness, we'll leave this option disabled for now. However, auto failover is crucial for maintaining service continuity. We'll enable that. In the cluster settings, you'll have the opportunity to specify key details such as the engine version, the ports, parameter groups, and node types. For this demonstration, we will select a micro instance type, which is cost-efficient. The available options include T2 micro, T3 micro, and T4G micro instances. Notably, both T2 and T3 fall within the free tier limits, making them excellent choices for those beginning their journey with AWS. Let's dive into the options available to us. We start with the T2 micro instance. Additionally, we have the capability to create replicas, which is essential for scaling, especially in cluster mode. For now, we're setting this to 0 to manage costs effectively. However, in a multi-AWS environment, having more replicas is advisable to ensure higher availability and fault tolerance. So, we will keep this at 0 for budgetary considerations at this stage. Next, I am going to set up a subnet group. This will help us define which subnets in ElastiCache will host our caching instances. We can select our VPC, Virtual Private Cloud, here, and you'll notice that subnet selections are automatically filled in. However, if you wish, you can manually specify the subnets. Regarding availability zone, AWS, placements, we have the option to designate which replicas will be deployed in each AWS. Yet, as we are not utilizing multi-AWS mode at the moment, this detail isn't critical right now. Moving on, we need to consider whether we require encryption at rest. Do we want to enable this feature? If you decide on encryption at rest, it's crucial to specify a key for data protection. Additionally, we want to implement encryption in transit to secure data traveling between our client and the server. Enabling encryption in transit also grants us access control features. For access control, we can utilize Redis Auth, where a password and auth token are required to connect to our Redis cluster. Alternatively, we can set up a user group access control list. You can easily create a user group via the ElastiCache console. In this case, I will opt to disable encryption in transit, but be mindful of your security requirements. Moreover, you can define security groups to manage network access to your cluster, helping to safeguard your resources from unauthorized traffic. Now, let's consider backup options. Are backups required? Additionally, we should think about maintenance. Do we want designated maintenance windows for executing minor version upgrades? Also, do we wish to enable logging, such as slow logs or engine logs, which can be integrated with CloudWatch for monitoring and analysis? Lastly, do we want to apply tags for better organization and management? There are numerous options available to us. This process is quite similar to what we experienced with Amazon RDS, so I am moving through these selections a bit more briskly. As we can see, we have explored various configurations essential for creating our cache successfully. Now that we've gone through all the configurations, let's review everything and click on the Create button to finalize the creation of our cache. My ElastiCache instance is now up and running. If I had developed an application, I would utilize the primary endpoint for data access, or the reader endpoint in case of a read replica, to fetch data from my cache effectively. However, demonstrating how to connect to a Redis cache is somewhat complex, as it requires you to write specific code, which could complicate things unnecessarily for this tutorial. Instead, I want to highlight that from the AWS Management Console, you can access comprehensive details about your ElastiCache setup. This includes information on nodes, performance metrics, logs, and important network security settings. It's worth noting that ElastiCache shares similarities with Amazon RDS, as both are managed services tailored for handling specific types of data storage and retrieval. While RDS focuses on relational databases, ElastiCache is optimized for in-memory caching using Redis and Memcached. As we wrap up, if you decide to remove your Redis cluster, simply navigate to the Actions menu, select Delete, and when prompted about backups, you can choose No. Just type in the name of the cluster to confirm the deletion, and you're all set to conclude this hands-on activity. That brings us to the end of this segment. I hope you found this tutorial informative and engaging, and I look forward to seeing you in the next lecture.